Hello everyone. Today I'll start with chapter hydrogen. So, as we know that hydrogen is the most abundant element and it exists in the earth as H2 gas and with other compounds joining with the other elements it form different compounds. So, what is the electronic configuration of hydrogen? Electronic configuration. Electronic configuration of hydrogen is 1s1. So when you represent any element, how do you represent it? You represent it by Z and A, where X represents the symbol for the element, Z tells about the atomic number, A tells about the mass number. So for hydrogen, we have 1H1. But so also atomic number, what is atomic number? Atomic number is number of protons, or you can say or number of electrons. Okay, mass number, which is A, is actually number of protons plus number of neutrons. We know that in an atom, this is an atom, it has one nucleus. So the nucleus contains protons plus neutrons, whereas the shell contains electron. So mass number is actually the sum of number of protons plus number of neutrons, whereas atomic number is either number of protons or number of electrons. So depending upon the so depending upon the number of neutrons present in the nucleus, hydrogen has three isotopes. One is 1H1, another one is 2D1, and third one is 3D1. It is hydrogen that is present in the most abundant form. This one is deuterium. This one is tritium. So here if you are asked to calculate number of neutrons. How will you do that? Since this mass number is the sum of number of protons, so I can say number of protons plus neutrons. So mass number is 1, number of proton or electron is 1, so number of neutrons will come out to be 0. While in case of deuterium, mass number plus number of protons plus number of neutrons. Mass number is 2, number of protons are 1, so number of neutrons will come out to be 1. In case of tritium, where mass number is equal to sum of protons plus neutrons, so mass number is 3, number of protons are 1, so number of neutrons will come out to be 2. So now comes the factor, since configuration is electronic configuration is 1s1. So where should it be placed in the periodic table? Helium has an electronic configuration of 1s2, and hydrogen has one electron less than the noble gas configuration, one electron less than noble gas configuration. So, since the halogens group 17 family, that is fluorine, chlorine, bromine, iodine, these all contain p5, that is one electron less than the noble gas configuration, that is group 18, where neon etc. are present, which contains S2P5, that is S2P6, NS2P6, NS2P5, NS2P6, and NS2 and NP6. So one electron less. So it could be placed in the halogen group, or if we consider alkali metals, that is group 1, that is lithium, that contains 1s1, 1s2, 2s1 electronic configuration. It is one electron in its s orbital. So we can say that either it could be placed in the alkali metals or it could be placed in the group 17. So now we look for the similarities with alkali metals and similarity with halogens. Hydrogen can lose one electron to form H positive an electron, similar to the sodium or lithium case. These can lose one electron to form this lithium plus ion, and like this. So this similarity is the halogens, while ionization energy, which is the energy required to remove one electron from the atom in the gaseous state. So delta H ionization energy of fluorine F2 is 1680 kilojoule per mole, while for hydrogen it is 1312 in the atom state, no, atom from in the gaseous state. So these are similar. So also hydrogen in nature exists as H2, fluorine exists as F2, chlorine exists as Cl2. So this similarity in the existence also suggests a similarity with the hydrogen, similarity with the alkali metals. You have seen they get ionized. So where should we place hydrogen? Since hydrogen is showing similarity with both the atoms, it can lose one electron. It can lose one electron to form H++ electron, or it exists in the form of H2. Thus, hydrogen is actually placed separately in the periodic table. That's all for today.